Okay, in this video we'll start combining atoms together to form ionic compounds and how you do Lewis structures for ionic compounds. So, in order to do ionic compounds, you have to understand a concept called electronegativity. The more qualitative description or definition is the ability of an atom to attract electrons to itself when in a bond. Okay? And there's an actual mathematical formula for calculating the ability of an atom to attract electrons. But for our purposes, I kind of think of it as like how you rate movies. You know, you go see a movie and someone asks you, how many stars was it? Well, a 5-star movie is a really good movie, and a 1-star movie is a really bad movie. Similarly, atoms are rated on a scale from about 1 to 4. 4 being super attractive, and 1 being, or 0, I'm sorry, is a scale from 0 to 4. 4 being very attractive, 0 being not attractive at all. So, fluorine is the most attractive atom on the periodic table with an electronegativity of 4.10. And for our purposes, I'm going to abbreviate electronegativity with En. One of the least attractive elements on the periodic table is francium with an electronegativity of 0.86. Okay? Where am I getting these numbers from? I'm getting these numbers from Appendix O, and you can Google them online and just put electronegativity table. But I'll just show you Appendix O here. Here's Appendix O, all right? And it lists all the electronegativities for all of the atoms. And you can see fluorine in the upper right-hand corner with an electronegativity of 4.1. And in the lower left-hand corner, you can see francium with an electronegativity of 0.86. Okay? So when you do ionic compounds, the first thing you have to do is take the electronegativity difference. And the difference is taken between the two atoms. So we're going to do this with sodium chloride. So you have the sodium and you have chlorine. Sodium is in group 1A, so it has 1 electron. Chlorine is in group 7A, so it has 7 electrons. Now, instead of using dots, I'm going to use X's to indicate the 7 electrons. Okay? Now, when you start making bonds between atoms, you really can put the dots anywhere you want. So I'm just going to put that electron over there. Okay? The electronegativity of sodium is 1.01. I got that from Appendix A. The electronegativity of chlorine is 2.83. So what I'm going to do is I'm going to take the absolute value of the difference, and that comes out to be 1.82. Okay? If the difference is 1.7 or higher, you have an ionic bond, and one atom, or I should say the more attractive atom, or the stronger atom, steals the electron from the weaker one. So ionic bonding is stealing. One atom actually takes the electron from the other one. So in this case, chlorine is stronger. So it is going to steal sodium's electron and take it. Okay? When you are done with Lewis dot structures for compounds, not single elements, for compounds, all of your electrons must be paired. So you can see every electron is paired up here. Now, because the chlorine gained an electron, electrons have negative charges. Because it gained one, it is now going to have a -1 charge. So I put brackets around it, and then I write the charge up in the corner. Sodium has lost its electron, and it has brackets around it and 1+. Remember, if you have a positive charge, you call it a cation. Am I sure? You bet I am. I'm positive. And if you have a negative charge, you would call the anion. So for ionic compounds, there should never be any electrons around the cation when you're done. And for the anion, you're going to have 8. Okay? So then what causes the sodium and the chlorine to stick together? You'd think that the sodium would be pissed off because it had its electron taken from it. The reason why the sodium and the chlorine stick together is because opposite charges attract. And so the sodium and the chlorine stick together even though chlorine went and took the electron from the sodium. Okay? And so all ionic compounds, all ionic bonds are an attraction of positive charges towards negative charges. Okay? So let's do another example. How about we do barium bromide. Yep, let's do barium bromide. Here we have 3 atoms. Okay? The one with the fewer number of atoms is put in the center. So there's only one barium, so it goes in the center, and then the 2 bromines are put on either side. Okay? The barium is in group 2A. So it starts with 2 valence electrons. I'm using X's here so that we know they're the bariums. Bromine is in group 7A. So it starts with 7 valence electrons. Okay. Now, we go to Appendix O and we look up the electronegativity of barium. And the electronegativity of barium, and there's also an electronegativity table in your book. Barium is 0.97, and bromine is 2.74. Okay? So you take the difference just between these two. Okay? So when I take the difference between those two, I get an answer of you get an answer of 1.77. So if it's above 1.7, it's ionic. Okay? Then you redo the calculation for the other one between these two. Obviously, if I redo the calculation between those two, I'm going to end up with the same answer. Okay? And in a more complicated molecule, it is possible that you would not have the same 2 atoms. So it could be that you would have something like barium bonded to 1 bromine and then be bonded to an iodine on the other side. So you do between those two, take the difference, then between those two and take the difference, because it's possible that this bond would be ionic and this bond would be covalent, which we'll learn about later. Okay? So anyhow, both of these bonds are ionic. So then that means there's going to be stealing going on. The bromine is stronger, so this one steals 1, and the other bromine steals the other. So this becomes a -1, this becomes a -1, and this barium lost 2, so it would be a +2 charge. Okay? And that's how you draw the Lewis dot structure for barium bromide. Let's just do one more example. Let's do strontium fluoride. So strontium is in group 2A, so it starts off with 2 electrons. Fluorine is in group 7A, so it starts off with, whoops, can't do strontium fluoride, just kidding. Let's do magnesium oxide. Okay, so magnesium is in group 2A, so it starts off with 2 electrons. Oxygen is in group 6A, so it starts with 6 electrons. Now, like I said, when you're doing compounds, you really can put the electrons anywhere. You don't have to put the S's on that side and the P's on the other side. You can put them anywhere you want. Only when you're doing single elements would you have to do that. Okay? But we're not doing a single element. We're doing a compound between magnesium and oxygen. Oxygen is 3.50 and magnesium is 1.23. So I take the absolute value of the difference, and that's going to give me .27. Okay? So that means the oxygen is going to steal these 2 electrons from the magnesium. Now here the oxygen stole 2 electrons, so it's going to have a -2 charge. The magnesium lost 2, so it's going to have a +2. And that's how you do the Lewis dot structure for ionics. I also have videos of me in class teaching this from a few years ago, so if you're interested in watching those videos instead of this, you can.